Hi, I'm doing this quickly again. If you look at H2 plus O2 gives you H2O, just the normal water reaction. So what these small numbers means is that in each molecule, I think you know this already, there's going to be one hydrogen and there's going to be another hydrogen attached to each other. It's a diatomic molecule, and then the oxygen would be the same. I'm just going to use another color. So that's the oxygen and the oxygen, and we're adding those together. And then the molecule that we form. So I always like doing the particle diagrams because then you can clearly see what's going on. So if you look at the molecule that form the water molecule, you've got one oxygen and you've got two hydrogens. So if you look at this, you've used both hydrogens, but you've only used one oxygen. And an oxygen atom cannot disappear. Whatever is on this side, that's the law of conservation of mass. Whatever particles are on this side must be on that side as well. So if I used one of these there, I used that one. I now have to use another one, and I already used two of the hydrogens. So there I've used my two hydrogens. So now I'm going to have to use another two hydrogens to form another H2O. So these small numbers can never change. That's the bonding. I don't know if you've done that yet, but that's the bonding that you cannot change. That's got to do with the electron configuration from the periodic table. So if you've done that, you know why it's H2O. But even if you haven't, for balancing, you can now see that we need two of them because there are two there. But now we've got a problem because now there's one, two, three, four hydrogens, and on the other side there's only two. So I'm going to have to make another. I can never just add one. I always have to add a whole molecule. So I've added another molecule. Now, the balancing, those big numbers, just tells me how many of these particles do I need. And when you get to moles, you'll know how many moles. But for now, how many hydrogen gas particles do I need? So now we're going to put a big 2 in the front because that means I've got two of these. I'm going to leave that out. You can put a 1, but we don't put it if it's a 1. So the 1O2, and that's going to form for us 2 of these H2O molecules. So that the big number is balancing the number of particles on the left-hand side and the right-hand side. So for the water one, that's pretty simple. So you don't always have to draw the particle diagrams. I like doing it because then you can see what's going on. But if you count, you've got two hydrogens on this side, you've got two hydrogens on this side. So your hydrogens are okay for now. Then you go and see, okay, for my oxygens, I've got two on this side, but I've only got one on this side. Now I want to make it two. So I'm going to always put a big 2 in the front. You're not allowed to add any small numbers. So I'm putting a big 2 in the front. But as soon as I put the big 2 in the front, I've now messed with my hydrogens as well. My hydrogens are not 2 anymore. I've now got 2 times 2. So 2 of the whole thing. So 2 times 2 and 2 times 1. So 2 times 1 is fine for the oxygen, but 2 times 2 gives me 4 hydrogens, and that means there's 2 already here, but I need to double that to get 4. So that means that, yeah, so it's the same as the balancing we've just done with the particles, but you'll see once you get used to it, you'll just count like this, and you don't have to draw the particles anymore. But let's just do that one more with the particles. So if we're looking at this one, it's a bit different. So if we're looking at P4, P4 means there are 4 P's in that molecule. And then we've got an O2 again. So OO. And then I form my product, which is going to be the P2. Now I can start counting that already because I've got P2, I've only got two P's, and then I've got 5 oxygens. So I need to do 1, 2, 3, 4, 5. You don't have to worry about how you do them at the moment when you draw the particle diagrams. But now we can see again, we've used 2 of these P's. There are 4 of them. So I already know I need to at least do another 2 P's. And with those 2 P's, because it's P2O5, I'm going to form another 5 oxygens. Now I have to, so my P's are sorted now. So I've got 2, 4, I've got 4 here. So the P's are happy. But now I need to count my oxygen. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side. And if there's 10 on this side, that means I'm going to need 5 of these to make it 10 on this side as well. And I think it's balanced. I thought it was a little bit more complicated than that, but let's see. Is it balanced? It is, yeah. So now I actually wrote the number instead of drawing it. So I would then draw, green, draw, 2, 3. So that's 2, 4, 6, 8, 10. And once you see that you've 10, you can see that there are 10, as same as on that side. There's 1, 2, 3, 4, 5. So now we're going to put a big 5 in the front there. We're going to put a 1. Remember, if it's a 1, you don't have to put it. And then we're going to put a big 2 in the front there because there are 2 of those whole molecules. So that is then again balanced. If we didn't do the particle diagram and we just counted, then you're going to say to yourself, this side I've got 4 P's. On this side, I've only got 2. So I'm going to double it. Just start. It might not be right, but just start with something. So I'm going to double it. Now I've got 4 P's on this side, which means my P's are happy. But now I need to check my O's. If I put a 2 in front, it means I've got 2 times 5. So that means I've got 10 oxygens on this side. And on this side, I've only got 2. So if I put a 5, 5 times 2 is 10. And I've got then 10. So it's balanced. Okay, I hope that makes sense. I'm just going to do another, or I don't know if you want to, you can just pause it and go and see if you can do these. Because it's not always going to just be 2 things. It could be 4 like it is here. So here we can see there are 2 carbons. So I just start with anything. There are 2 carbons there. There's only 1 carbon there. So I'm going to put a 2 in front here. Then I look at my hydrogens. There are 4 hydrogens there. There are only 2 there. So I'm going to put a 2. Now it's 2 times 2, it's 4. 2 times, but now I need to just sort out my oxygens because oxygen is in 2 different things. So that makes it a little bit more tricky. So I need to look at how many oxygens I now have here. So it's 2 times 2, which means I've got 4 oxygens there. 2 times 1, which means I've got 2 oxygens there. This molecule has already got 2. So if I put a 4 there, then, oh, sorry, that's 6. So if I put this needs to be 4, so I'm going to put a 2 there if I want to keep that 1. Because if I now go and change this, I change those numbers as well. So then you just have to fix them. And then you'll see you'll end up with a multiple that you can divide it to simplify it. And then that's not right. They said leave an empty space if you need 1. So we don't have to put the 1 there in front. So now let's just count. 2 carbons, 2 carbons. 4 hydrogens, 2 times 2, 4 hydrogens. Oxygens, there are 2 there, and there are 2 times 2. So there's 4 plus 2 is 6. Here on this side, there's 2 times 2 is 4. 2 times 1 is 2. So there's 6 on the one side and 6 on the other side. Okay, so it's just counting, but let me know if you want me to do more of them.